Let's record it. Okay, so we are doing lessons 5 and 6 from geometry today. I don't know why that title stayed on there. I really thought I changed everything. Anyway, ignore that. Parallel lines are two lines in the same plane that never intersect. So if we use our symbols here, if we have line AB and we want to see where that intersects with CD, the answer is never, or empty set, because these two lines are parallel, and no matter how far out we go, forever, never, never, if I could draw straight, they would never cross. Okay. So the symbols for saying that line AB is parallel to line CD, we're going to use our line symbol, and then this is our parallel symbol. And we remember from our book that the dragons, the pair of lels, had their necks straight across, right? So that's how we can remember that. All right, so this symbol is one that you might want to take on your notes. That's how we can say that two lines are parallel. You could also do that set notation of where they intersect and it's never. That would also mean that the two lines, if they were in the same plane, are parallel. I won't get into if they're in two different planes, they could never intersect also, but. Okay, why is it not? Oh no. There we go. Nope, now I went too far. I think my computer is slow to respond. Here we go. Perpendicular lines. Two lines or rays or line segments that intersect and form a right angle are called perpendicular lines. So when we have lines that do that, if we see the picture, we can draw that little square in the corner to show that they're perpendicular lines. They form a 90-degree angle, so they are perpendicular. If we want to write that out in symbols, we have line EF, and then this is our perpendicular symbol right here. Line EF is perpendicular to line GH. So again, this is our perpendicular symbol. It's because it forms a little perpendicular lines. So like an upside down T. All right. We will wait for my computer to respond and advance the slide. I don't know what's going on, y'all. Okay, so the next thing, well, there went too far. Something is a point that marks the center of a line segment, the center being the exact middle. So that would be a midpoint. It's exactly in the middle, so it's a midpoint, the point that marks the center of a line segment. It has to be a line segment because the line is going to go on forever. But if we have a line segment, then we know how long it is and we can cut it exactly in the middle. That would be the midpoint. Something is the line that cuts an angle in half. And then I give to bisect means to cut into two equal parts. So if we're cutting an angle in half, we call it an angle bisector. It is the line that's going to cut the angle in half. I use line loosely in this case. It will probably be a ray. So if we have this angle, my PowerPoint does not like me today. Okay, I'll draw with a dotted line. Here we go. You cut it in half with this ray. This would be your angle bisector. It cut the angle in half, and now this angle and this angle are congruent. All right, and something is a line or segment that cuts a line segment exactly in half and does so at a right angle. We learned that perpendicular means that it will come in at a right angle, and that a bisector is something that cuts it in half. So a perpendicular bisector is going to be that line or segment that cuts another line segment exactly in half and does so at a right angle. So it forms it right here. This side is equivalent to this side. So these are my little symbols that are just saying that this side is congruent to this one. And so this right here is the perpendicular bisector. Okay, now we're going to move on just a second, if everything will work. It's just taking forever to respond. I have some other slides that will show us how we can form, how we can find the midpoint of a line segment without a ruler, and how we can find the angle bisector without a ruler or a protractor. So all you need for these is your compass. I'll go through it once and then we'll do it together as you can do it on your notes. I think there was some space for that. All right, this is really frustrating. The PowerPoint won't close for me to find the next one. All right, I may have to stop things for just a second and see if that helps at all. Yes, it does. Okay, let's close that one. Okay, we're going a little bit out of order. So if you turn your notes over, well, anyway. No, don't do that to me. Okay. I promise I do this all the time. I used to. Okay, here we are. Now, this was a PowerPoint made for another class, but a lot of it is still very useful. So the constructions, that's how we're going to draw all these things with just our compass. The constructions, what that means is just to construct a segment or an angle or a bisector of an angle. So a construction uses only a straight edge and a compass to create a geometric shape. So you still probably might be using a ruler just so that you can draw a straight line, but not because we're actually measuring things. And then your compass will do most of the work. We're going to skip this one real quick. All right, and then an angle that's the same. Okay, so I think it's on the back of the first page or something, is a bisector of an angle. So I'm going to go through it once and then we'll go through it again as you can do it with me. So if we have this given angle, we first, if we want to create the bisector of it, if we want to figure out where to divide it in half, we first put our compass needle on the vertex. So I know in this picture it looks a lot the same, but this is the pointy part and this is the pencil part. So you put the pointy part right there on the vertex, and then you're just going to draw an arc, part of a circle, across the angle. So here you're going to draw an arc across the angle. And then we're going to put our compass needle at the arc and angle intersection. So one of these points, it doesn't matter which one because we're going to keep the same the whole time. But if you put it on this point right here, so you now move the compass so that the pointy part is right here where you made that intersection. You're going to draw another arc out here. And then you're going to move the pointy part to the other side and keep the compass the same. So that's the key right here. Once you've drawn this arc, you want the compass to be the same because you're using that as like a measurement that's going to make the same arc. So then you move it over to this one and you draw another arc. And then you can see where these second and third arc intersect right here. If you connect that point and the vertex and draw a straight line, that will be the angle bisector. Okay, so we're going to go back and you're going to do it with me if you have your compass. So I'll go through it one more time. All right, you're going to start with the pointy part of your compass on the vertex of the angle. Pick a length for your compass that's not longer than the angle. So somewhere between the end of the angle and about the middle. If you can get it around the middle, that would be good. If you get it really, really close, it's going to make all of these so small that it will be hard to find the exact middle. So you want it somewhere out here when you draw your arc. Now, if you have that a good distance apart, you can keep your compass the same. Whether your compass stays the same between the first and second arc is not really a big deal, but it must stay the same between the second and the third arc. Okay, so once you have one arc across the angle, all you've done is really marked this distance on the first ray and this distance on the second ray as the same length. That's all that arc is doing. So you're going out a certain distance on the first ray. Now you're going to put your compass where the pointy part is on that intersection, that certain distance, and you're going to make another arc out in the middle of the angle. This is where you need to keep your compass exactly the same distance apart and just move it over to that other intersection of the ray and the first arc. And now you make a third arc. So this is hopefully what you're looking at now. You find the intersection of that second and third arc. And then you draw a line from there back to the vertex. This is where you need a straight edge. If you have a ruler, you can use a ruler. If not, the side of a piece of paper works, as long as you didn't cut the paper yourself. Usually they give it to you in the package pretty straight. All right, so I think these steps are on your notes just to remind you and help you as you're going through. Does anybody have questions over that? Okay, I'm going to close this one. And I have one more PowerPoint. Okay. So here we have a line segment. If you need to, you can mark the endpoints just a little bit more. Whoops. You're going to put your compass needle on one of the endpoints and create a long arc going above and below the line. It needs to be more than halfway. So somewhere between halfway and the end, you're going to put your compass past the halfway and you're going to make a big arc that goes above and below it. And then you're going to keep your compass the exact same and just switch the endpoint that the pointy part of your compass is on. And you're going to draw a second arc above and below. So now you have this nice line segment with these two arcs. If you connect where the arcs intersect on both the top and the bottom and draw a straight line up and down, it will be the perpendicular bisector. So it is perpendicular. It also cuts this blue line segment in half exactly. So this side of the line segment is the same as this side, which makes this the midpoint. Okay, questions over this? Do I need to go through it again? Are we getting it? I didn't hear anybody. I think Alton, you're on mute. You're good? Okay. All right. I'm going to go back to the first PowerPoint. It hopefully will work this time. All right. Hopefully Mackenzie's back. All right. And this is working better. Okay. So that should have been all of lesson 5. You'll be drawing some angle bisectors. You'll be trying to find midpoints. You'll be identifying parallel or perpendicular lines. And then in lesson 6, we get into angles again. So first we're talking about adjacent angles. These are angles that share a common side and have the same origin. So that just means that they're next to each other. In this picture, does somebody want to tell me one set of adjacent angles? Anybody? Okay. Some of you are on mute, some of you are not answering me.
3 and 2.
Yes, 3 and 2. Awesome. Thank you. That was Matthew, right?
Yeah.
All right. Angles 2 and angle 3. They are right next to each other, so they share a common ray. So if we look at angle 2, it's ECF to make that angle. And then angle 3 is FCG. So the two letters that we heard next to each other that were the same are CF. So this is the ray that is between angles 2 and 3. So the ray that they have in common would be CF. We could also say that 1 and 2 are adjacent. So angle 1 is right here, DCE, and angle 2 is ECF. So that CE ray is the same between those two. I won't write the rest of them, but 1 and 2 are adjacent, 2 and 3 are adjacent, 3 and 4 are adjacent, and 4 and 1 are adjacent. All right, same picture. Which angles are not adjacent? Which ones are opposite?
4 and 2.
4 and 2, exactly. So angle 4 and angle 2 are opposite of each other right here. And then 1 and 3 are also opposite. These are called vertical angles. Oh, now it won't work. Okay. There they all come at once. Vertical angles, angles that share a common origin and are opposite of each other. So that origin or their vertex is C. And if you look, they use the same lines, you know, their rays here. So let me find a different color. Maybe. Never mind. Okay. So here, these two rays make up angle 1, and then exactly opposite, you know, CE is also connected to CG because they're still the same line. So that ray and then CD and CF are really the same line. So there, they use the same lines and the same vertex, they're just opposite of each other. Okay, so the two sets of vertical angles would be 4 and 2 and 1 and 3. Vertical angles are always congruent, so they have the same measure. 1 and 3 are the same measure, and 2 and 4 are the same. Notice how I'm marking one arc across these two to show that they're congruent, and then 2 arcs because 4 is not congruent to 1, but 4 is congruent to 2. So if I label them the same with that 2 arc marking, I guess, shows that they're congruent. I'm waiting on my PowerPoint. Hopefully it's coming up. It says if DF is a line and EG is a line, and the measure of angle 1 is 110, what is the measure of angle 2? So does anybody know what the measure of angle 2 is?
It would be 360 minus 110, right?
Just angle 2 with angle 1. Let me see. It's coming back. I can change colors again.
Is it 90?
Close. So DF.
Oh, 70.
Yes. So DF right here is a line. If angle 1 is part of that line and angle 2 is the other part, then the line, the total right here of blue is 180 degrees. Angle 1 is part of it and is 110. So then we take 180 minus 110. So you were getting there, just the wrong numbers. And then I think Matthew saw it too. Now it won't change again. So how did we find this answer? 180 for the straight line minus the 110 for angle 1 is equal to 70 degrees. I never labeled that over here. 70. So the measure of angle 2 is 70 degrees. If vertical angles are the same, if 2 is 70 degrees, what is angle 4?
It would also be 70 degrees.
Excellent. So angle 4 would be 70 degrees. And then 1 and 3 are vertical angles. So if 1 is 110, 3 is also 110. Okay, one more slide, if my computer will work with me here. All right, supplementary angles. These are angles whose measurements add up to 180 degrees. Or we can say together they make a straight line. However, the angles don't actually have to be adjacent to be supplementary. So they don't have to make a straight line to be supplementary. I could say that this angle over here plus this angle over here add up to 180 degrees. Even though they're not touching, they're still supplementary. So supplementary just means they add up to 180, whether they're touching or not. Complementary angles are angles whose measurements add up to 90 degrees. So they'll add up to a right angle, but again, they don't have to be touching. They don't have to be adjacent angles to be complementary. You could have an angle on one side of the paper and an angle on the other. If they add up to 90 degrees, they're still complementary angles. A memory trick of how to remember this is possibly that the S in supplementary goes with straight. So a straight angle is 180 degrees. Supplementary angles add up to 180 degrees. And then the C in complementary goes with the word corner, and the corner is 90 degrees. You can say hi to everybody. Okay, so in this picture, what are two complementary angles? Can you find two angles that you know will add up to 90 degrees?
1 and 2.
Yes, that's correct. 1 and 2. Where's my pen? There we go. Angle 1 and angle 2. And do you need to explain how you got that? Can you?
Can't really measure it because I don't have my thing on me right now, but they just look squared, sort of.
Okay, so I can tell you how you really know that. This line is going to be 180. It's a straight line across. And then if this side of the line right here is marked with that little corner symbol, that means it's perpendicular. It also means that this angle 3 is going to be 90 degrees. So angle 3 is 90 degrees. If the whole line is 180, then over here, angles 1 and 2 also have to add up to 90 degrees, which means that 1 and 2 add up to 90, and that makes them complementary. Identify the supplementary angles in the picture. Are there two angles that add up to 180?
One and three.
If you put 2 in there also, 1, 2, and 3 will add up to 180. And I think that's allowed. 1, 2, and 3. But also 4 and 5. If this is a straight line, then across a straight line is 180 degrees. So 4 and 5 will add up to 180 degrees. All right, our last problem is a little hard. Maybe not. Given that angle 4 is 42 degrees. So right here, angle 4 we know is 42 degrees. I'm going to erase everything. Well, maybe not. Find the measures of all the rest of the angles. So I'm going to erase some of this so I don't get confused. So I'll give you a minute, and if you're still lost, don't worry, I'll go through it all. So if you're trying to figure it out, I'll give you a minute to try to figure it out, and then I'll go through it. And then our meeting is going to cut off in 5 minutes. If you still have questions, you can sign back in and I'll answer them.
Angle 5 would be 138 degrees.
Okay. So this is where Alton started, and it doesn't matter. There's a lot of ways you could go through this. You could start somewhere else, but he's looking at angle 4 and 5 add up to 180. Here, I'll put a little measure in front of it to be more exact. So the measure of angle 4 is 42. So if this is 42, and then we add angle 5 and the whole thing equals 180, then we're taking 180 minus 42 and getting measure of angle 5. So he says the measure of angle 5 is 138. I think that's right. Something else that we've already identified is that angles 1 and 2 add up to 90. So the measure of angle 1 and the measure of angle 2 add up to 90. Is there something else from this picture that we could?
Angle 1 is 42, and then angle 2 is 47. No, 48.
Excellent. So 1 and 4 are exactly opposite of each other. So sometimes you're going to have to get used to trying to find the vertical angles because those are pretty key in helping us with a lot of these. So 4 and 1 are congruent, which means that angle 1 is 42 degrees. So we can substitute that in for angle 1. And then when we subtract from 90, you'll get that the measure of angle 2 is 48. Is that what you said?
Yeah.
Okay, someone correct me if I'm wrong, but I think that's it. Okay, and that's all of them now because we've labeled the one that was opposite that's congruent. We've subtracted to find the next one. We see that this is a right angle, so we can just label that as 90. And then over here with angle 5, we took the whole 180 and subtracted angle 4. I think these are fun puzzles as we get to learn more relationships between angles and lines. I think it's kind of fun to figure all of them out. That's it for the lessons. Does anybody have questions?